I'm Mike Reamer. I'm the Global Chief Technology Officer. And just say CTO, it's easier, right? And today we're going to go over some of the post-COVID secure access issues that we've seen in the field, and talk about zero trust and how to implement zero trust and what's next. So as we take a look, one of our first things that we want to take a look at here is Cybersecurity Insider's Endpoint did a report. And in this report, they're showing that 72% increase in instances on remote workforce folks. And these instances we'll take a look at in a second. But they run the gambit from credentials being hacked, as well as people just gaining access to information that they shouldn't be gaining access to. Of these individuals that were also highlighted in this report, we're looking at 50% or 56% are anticipating some sort of future compromise in their current footprint that they have. When we look at some of those incidences that they're talking about, quite a few of them are malware, ransomware, Trojans, those types of things. But it's that insecure network remote access. This is people's Wi-Fi's at home that don't have appropriate passwords and appropriate protection. Or somebody's laptop is connected to two networks simultaneously, and they're connected to an insecure network, or they're connecting up to the corporate network, and they're acting as a bridge for a bad actor to be able to get through and go through. And then, of course, compromised credentials that we just heard from Zero Auth as well. So trying to answer these questions and looking at these challenges that are sitting out there for individuals in the COVID environment, in the massive amounts of work from home issues that we have. So we introduced what's commonly now called in the environment zero trust. As our previous spokesperson there said, defense in depth. Nowadays we call it zero trust. And NIST defines zero trust as a cybersecurity paradigm focused on resource protection, and the premise that trust is never granted implicitly but must be continually evaluated. And how we interpret that into zero trust access and giving individuals or devices access is that we verify and authorize not only the user, but also the device that is trying to access an application or a resource on the inside of our network. So we want to do that not only at the time of authentication and then give them the authorization that they need to in a least privileged access mode, but then we also want to continually look at to make sure that their behavior is appropriate and do a continuous compliance check, and then adapt to what we see from that user. So if they're doing something we don't anticipate, or they're trying to gain access to a data store that they shouldn't, then we want to remove access, and we want to be able to do that dynamically while the user is connected. So when we look at zero trust as a holistic view, some of the key requirements within it, a lot of people want to say that I'm just going to give one solution and plug a solution in for zero trust. And it's really not a single solution. Zero trust is a holistic concept, and it's a coordinated control effort. And it's not just the method of connectivity or the method of authentication, whether you're using MFAs, or you're using single sign-on, or you're looking at an MDM solution for a mobile piece. Or if we're talking about on-prem and port level security with NAC, or CASB, which is more at that DLP level or application access perspective. It's a holistic approach, all the way from connectivity, all the way through the architecture of how you do connect it. So verifying the user, verifying the device, managing their level of access from centralized policy and granular access control, which we also call least privileged access. And then protecting that data once they are connected. And by doing this in a manner and moving from our traditional L3 VPNs, which the majority of the work home users are using today, and moving more to that SDP architecture, where we have that division of control plane and data plane, and we can utilize that new architecture to invoke security and security into any type of solutions that we do put in place. So when we look at specifically from Pulse's perspective, how we do zero trust in an SDP environment for access to hybrid environments. So this is, your applications are not only on-prem or in virtual private cloud or VPC, but also out in the public cloud. It could be SaaS offerings that we're trying to give the user a more expedited connectivity to, but still ensuring that continuous adaptive monitoring that we're doing. So from Pulse, our zero trust access, we have our client-initiated SDP. So the client turns around and based upon a communication from the client going to the controller, which is a SaaS-based offering in the Azure Global Cloud, the client logs in. The endpoint is checked, the geographical location of that user is checked, the user's credentials are checked. We validate if it meets our security posture for the endpoint, and we validate everything that we can about that information that we have from a policy perspective. If they pass, we grant that user connectivity, and then we pass their information, we pass it over to from the controller to the gateway, and we let the gateway know that we have an active session on the controller, and that active session we're going to pass over to the gateways to allow the client to communicate directly to the gateways. Because the authorization piece here is held at the controller, and that authorization is passed to the gateway on a just-in-time basis. So as a user goes to connect to the gateway is aware of the inbound session coming in, it's validated, verified between the gateway and the controller, and the client is allowed to connect to the gateways. The gateways then give them access to the applications in the backside based upon the policies that were pushed from the controller down to the gateway. This is the ability to give us the least privileged access mode so that the client only gains access to the gateways that they are entitled to. So not all users potentially would have access to all the gateways in the environment. And this creates what we call a dark cloud or dark network, so that there are gateways that are unreachable by a user. They wouldn't know what the address or the DNS and able to get to those devices. They're not advertised on the internet. So the only way you know of the existence of those gateways or be able to get to them is if the controller tells the client where the gateway is, so the client can reach through the gateway. And the gateway will only respond to an inbound packet from an established session that the controller has told it about previously. So this gives us that holistic view where we're now able to look at not only the endpoint, but we're able to look at the gateway that they're going through, the application that they're using, and the device, of course, that they're on at the same time. When we look at those in a viewpoint from the controller, what we can do is we can see these. There we go. We can see these in our visibility. So we'll give you an overall geographical map that'll be able to show you where your gateways are geographically, and then the numbers on the gateway tell you how many concurrent connections you have going through those gateways. The number of gateways that the controller support is an infinite number because of the fact that we're in the Azure Global Cloud, and we've got very elastic compute power there. And so as the need arises for our tenants within the cloud, we just increase compute power that we need. So really there is theoretically no limit to the number of gateways or the number of users that could be connected to the solution at any simultaneous time. Looking at some other viewpoints, so this is where we look at that continued adaptive risk score. So as that user is on, we see what time of day they log in. We know that they're appropriate business hours that they should be logged in, and if they somebody's changing my slides on me. We know that we don't have any type of user working outside of the business hours, or if they are, that's a risk score increase. So as a user turns around and either tries to access an application they're not authorized to get to, or the user is attempting to log in at business hours, or they're trying to log into a device that we haven't seen before, or come in from a geographical location that we're not familiar with them, that it increases their risk score. And as their risk score is increased, we can then reduce the level of access they have. So we can take away applications, we can take away those the connectivity that they have to specific applications based upon those risk scores. And then all of this information, these anomaly detections we have, of course, are all reportable so that we can generate threat reports, and we can output those threat reports so that they can be used for any type of certification or validation or governmental requirements as far as standards goes. Again, applying that CARTA score, or as we call it, continuous adaptive risk and trust assessment, to the zero trust networking solution, it gives us that adaptive access. So as users are connected, if they change their behavior while connected, we can go ahead and reduce or remove their access. This is that dynamic, flexible capability of the CARTA score. And this is one of the things that we see from a company perspective that we're anticipating to become more prevalent within corporate requirements as we go forward, and governmental agencies and their requirements as well. And the solutions are going to have to be able to do this adaptive risk and do it on a real-time dynamic basis. So ZTNA basically as a use case, looking at the advantages that we have, there's two types that you can look at it in two places, as a business use or as from a technical consideration. We look at the business case, basically trying to simplify remote access for users, give them that single point of entry, which is the controller, and authentication and authorization through the controller, and then the intelligence of the policy on the backside, give them the connectivity to the gateways that they're looking for. Being able to scale for those work from home users, so that you have that flexible compute power that you can add dynamically or reduce based upon usage, so that you're not paying for compute power that you don't need or you're not using. Being able to reduce that attack vector or breach prevention by giving you that dark cloud, giving you that presence of the gateways not being known to any bad actors and only being known to authorize authenticated sessions and active current sessions. And then being able to roll out gateways on an as-needed basis to increase compute power at the gateway level. So if you've got a spike in user traffic and you have the need for more throughput requirements, you can do that with rapid provisioning. From a tech side, we want to make sure that we've got all types of applications that we support, not just web-based applications, but any based, BDI environment that we want to go into with HTML5, or we want to go in, either with an RDP type of solution doing over a specific IP port protocol. Being able to do this for not only on-prem applications, but for cloud-based applications, and some that may require hairpinning on a network in order to be hidden behind a specific IP address for access to that SaaS-based offering. And then having that overall visibility so that users can know the user, the device, the gateway they're getting through in the application, regardless of what the application is or where the user are. One more thing is as well, when the user connects up to the gateway, as the data flow goes from the internal resource through the gateway, we do not hairpin the data off of our cloud-based controller. It goes straight from the gateway right to the user's endpoint through the tunnel. So we call that data sovereignty. And what that does is it allows for the controller piece of our solution not to be involved in the data flow. So we never actually see the data itself coming through our solution. However, it does pass through our gateway, so we can monitor that information and we can report up to the controller, but the controller is not involved in that. So holistically, when we look at the solution, we want to make sure that we mobile access, application access, network access, and cloud access. These are not islands of access control. We don't want to individualize these. We want to be able to pull them all in, utilizing them in one solution where we've got our users and our devices being able to come through that solution and give access to that back end wherever we want to be able to give that back end to. Again, from an access control perspective, we want to take those tenants that we currently see and have, where they're firewalls or their WAS solutions or their CASB solution, VPN, regardless of the location, over SD-WANs, branch offices, remote offices, and we want to take all of this solution and we want to consolidate it all together. We want to pull it into a single solution where we have all of those mechanisms feeding in and plugging in, and that creates that zero trust edge, ZTE or SASE that everybody is so after. Now, you're not going to get that SASE from one specific vendor, and it's going to take a converged solution that plugs in, but Pulse really has the center of that with our controller and our gateways and our access that we provide. And then we allow for those types of plugins from the other solutions like CASBs and SD-WANs and things of that nature. So here we've also included a consolidated project plan for you. So as you look at Zero Trust, we've given you some key requirements, some consolidations, considerations, things to watch out for, and what you can expect as you move forward with your implementation. And this will be available for download from you. A little bit about Pulse very quickly. We've been around for a long time. We were part of a previous network. Previous company. We broke out about 6 years ago, but we still have 17 years of our heritage there. Over 21 million endpoints are connected to our solution on a daily basis and authenticate to us with a very rich, robust portfolio. And there is more information that you can download at our website. So thank you very much, and I appreciate your attention today.
Great. Thanks, everyone. And Mike, I have a question for you that I think is highly relevant since you talked a bit about data sovereignty. Do you offer the option to host the controller ourselves if we need to have an on-prem controller?
Yeah, so we do offer both the SaaS-based controller and an on-prem controller. In the SaaS-based solution, there is an instance of it that is owned by Pulse, and customers can subscribe to that as their own tenants within that controller that we own and manage. Or we do have several MSPs that are offering their flavor of the controller as well. And then, as I said, we also have the on-prem instance that customers can run both in hardware and virtualized format.
So just to sum up, people can go directly to you for the SaaS. They can go through some of ours, or they can have it on site. Is that correct?
That is correct.
Excellent. Well, thanks very much for being with us today.